Hi, this is the lecture overview for 1.7. It's actually going to be very quick. 1.7 is a section that has three types of things going on: mixture, uniform motion, and constant rate, which is what I call job problems. Anyway, these are three different word problems, and if you've ever done applications before, you know they take quite a while. The one thing I will suggest is you read the problem more than once. Don't give up. Don't even go in the first time you read it as if you're going to get it the first time you read it through. So I would say read at least twice before you start attempting to start breaking things apart. But the biggest thing is on every one of these kind of problems is to try to determine which of the three things you're dealing with. Is it a mixture problem? Is it a uniform motion problem? And because uniform motion problems are going to require a formula, and all this will be discussed in class. So I gave a little quick example of how this works on the mixture. Actually, I gave a mixture problem, and but like I said, I can't do a problem for every situation. I would this little lecture here would probably take me about 25 to 30 minutes to do it any kind of justice at all. And so for time constraints for these little overview things, I decided to do one. And I don't know how much help this is going to be, but this should help you with the mixture problems at the very least. So, um, but anyway, so come to lectures. So, a candy store sells boxes of candy containing caramels and creams. Each box sells for $12.50. And holds 30 pieces of candy. And some of those 30 pieces will be creams, and some of those 30 pieces will be caramels. Caramels cost 25 cents to produce, while creams cost 45 cents each to produce. How many of each is needed in each box to produce a $3 profit per box? So they want $3 a profit per box. That means the box cost them $9.50 to make, because they're going to sell it for $12.50 right here, and they want $3 a profit. You're like, why is that $9.50 important? Well, it's important because that's what everything is considering, is how much it costs to make each type of candy. So it is a mixture kind of problem, and so you have some that are caramel. So we have the cost for the caramels plus the cost for the creams. Okay, should be the cost of the whole box, which actually is going to be $9.50, because you got a $3 profit. So what is the cost per caramel? Well, you don't know how many caramels you have, nor do you have creams. So what I'm going to do is I'm going to define my variable as x, and that's going to be the number of caramels per box. Now, you have 30 in the box altogether. So what is not a caramel must be a cream. So if you have X number of caramels, that means you have whatever's left, which is 30 minus X, and that is the number of creams. And a lot of people ask, well, can't you have that backwards? Can't you let X be the number of creams? Sure, you can. The answer will be a little different. You will be solving for one thing, but you probably have to answer both questions anyway, so it really won't matter. So X is the number of caramels. I decided to do that. So what is the cost of the caramels? Well, it costs 25 cents to produce each one of them. So it's going to be 0.25 times how many you're going to make, and that's going to be X, because I don't know how many that is. Now, the cost for the creams is 45 cents each. So it's going to be 0.45 per one, and then times 30 minus X. And that's going to be cost for the creams. But like I said, it's going to cost you $9.50 to produce. And if you notice, $9.50 was never in the problem anywhere. You kind of had to decipher that number on your own. So it's not always very easy to do these things. So you do the math, and so that's going to be 0.25x plus 0.45 times 30. And let's see, I believe that's like 13.5. if my math is correct, and then 0.45 minus x. So 0.45x equals 9.50. Then what we're going to do is we're going to take 0.25x minus 0.45x is a minus 0.20x. I believe that's right. And then subtract 13.5 to the other side, And I believe that is going to be a -4. And then divide both sides by -0.20. Now, forgive me if my math is slightly off, because I'm doing this in my head as I go through here. So if I make a calculation there, it's your job to catch me. You got the calculator. Actually, I got one too, but I'm going to try to do it without. It takes too much time to do these things with a calculator sometimes. And I believe X would be 20. So if you do the math, that's 20. So 20 is X. Well, if you remember, 20 or X referred to the number of caramels. So it looks like you got 20 caramels. And since you only have 30 pieces in the box, you're right, that should be 10 left for the creams. I understand you're sitting there thinking, well, I couldn't do this by myself. You're not going to be great at it at the very first unless you've done these before. So it's going to take a little bit of patience. And I didn't want to sit here and struggle with it, okay, on purpose anyway. And so I wanted you to see that the problems are doable, and you can do them too. It's just going to take time. Applications are not easy for most people. So if this is not easy for you, you're probably not alone. It's very important to come to class during the lectures to catch all the nuances that you're going to miss off of these little lectures here. So, but anyway, that's it for 1.7.